हेलो स्टूडेंट्स। वेलकम है आपको हमारे चैनल पे। तो चलिए आज शुरू करते हैं इलेक्ट्रोस्टैटिक्स का जो सेकंड लेक्चर है। काफ़ी गैप हो गया है फर्स्ट लेक्चर और सेकंड लेक्चर के बीच में ड्यू टू सम टेक्निकल इश्यूज। वी हैव रिजॉल्व्ड इट। नाउ लेट अस कंटिन्यू विद continuous classes. So whatever we read in lecture 1, we are going to continue it in lecture 2. So lecture 1 we studied about electrostatic force. There is an electrostatic force between two charged bodies, okay, at rest. And that force we take the help of Coulomb's law of electrostatics to calculate that force, to calculate that magnitude of force. So we are now going to introduce a new concept today. So, what did we learn? We learned that there is some charge, it is a charge, and here is some charge Q2. If they are similar in nature, then the electrostatic force between them is this charge is repelling this charge in this direction, and this charge is repelling this charge in this direction, and this is a force or action at a distance force. This is action at a distance force. That means there is no direct contact between them. There is no direct contact between them. For example, what is direct contact? This is a marker and I am lifting it. I have to directly get hold of it in order to lift it. But see, this charge is applying a force on this charge without even touching, and this force is known as non-contact force. So in this case, we learned that it is called electrostatic force. But and in order to understand this force, we need to assume or consider a field known as electrostatics field. So let us now take our view on electrostatic field. So we are just removing it. So what is electrostatic field? Electrostatic field or electric field, whatever you can say, it is denoted by E. In order to uh, explain electrostatic force, we have to explain electric field. So what is electric field? If we consider an amount of charge on an object or a charged object, this is some charged object Q is placed at some point. So since it is charged, it is modifying the space around it. It is modifying the space around it. So that modified portion of that space is called its electric field. That modified portion space is called electric field. So how do we know there is electric field? How do we know? So हमें कैसे पता चलता है? यह है चार्ज, हम इसके पास में दूसरा एक चार्ज रखते हैं। चलिए इसका जो चार्ज है इसको ऊपर लिखते हैं और ये पॉइंट O पे है। It is situated at a point called O. Let us consider a point P where another charge Q naught is placed. In order to detect this electric field, we need to put another charge at any point P. So there should be a force between them, and this charge is feeling this force. This charge is feeling this force. If it is feeling that force, if it is being exerted by a force, then we can confirm that there is an electric field at this point due to this charge. There is an electric field at this point due to this charge, and this charge should be stationary. This charge should be stationary. It should be at rest. So let us now come to the definition of electric field. So what is electric field? It is the force experienced by some unit positive test charge. It is a unit positive test charge. So what is electric field? It is the force experienced by a unit positive test charge kept at a point, kept at any point P due to a stationary source charge. Due to a stationary source charge. So qualitatively, we can define electric field as qualitatively. Let us write the definition here. Qualitative, the qualitative definition, and then we are going to introduce the mathematical definition. What is qualitative definition? Qualitatively, what is that? So qualitatively, electric field of, it is called a source charge. First of all, it is called source charge. Electric field of a source charge at a point is defined as the amount of electrostatic force on a unit positive test charge kept at that point, and the main condition is that this source charge should not be disturbed, kept at that point, and or we can write without disturbing the source charge. So I assume that you understand the concept of electric field. So it was the qualitative definition. Let us now come to the mathematical definition. Mathematically, we can write mathematically, mathematically E equal to F by Q naught, force per unit positive charge. E is a vector quantity, F is also a vector quantity. So this is the mathematical definition of electric field. But this seems to be incorrect. This seems to be incorrect. Why this is incorrect or how it is incorrect? So it is the force experienced by a unit positive test charge whose dimensions should be small enough to get ignored. But we can't ignore its presence. We cannot ignore its presence. But we can ignore its dimension. Like it should be so small that it approaches zero, not exactly zero. So we are going to modify it. Then what should we write? E equals to limit Q naught tends to 0, not exactly 0, tends to 0, F by Q naught. That is the actual definition of electric field. You need to write like this. This is also correct, but you need to write like this in order to get good marks in exam. So this is the real concept of electric field. Now let us find out some miscellaneous things like its units, its dimensions, and other things. Then we shall be continuing to its characteristics and some other things. Okay. So let us first find out its unit in SI. What should be its unit in SI? So as we see, electric field is force per unit positive test charge. So what is the unit of force in SI? It is Newton per. What is the unit of charge? This is charge in SI is coulomb. So unit of electric field Newton per coulomb. What is that? Newton per coulomb. Now let us come to the dimensions. Dimensions of electric field. What should be the dimensions of electric field? And this is a question you might get in exam. It should be asking what are the dimensions of electric field. So it should be the dimensions of force divided by charge. Like what is the dimension of force? M1 L1 T raised to the power minus 2. And what are the dimension of charge? A1 T1. As you know, we can algebraically add them. Like M stays like this, M1, L stays like this, L1, A goes to above, comes A to the power minus 1, T becomes minus 2 minus 1, that is, this is the dimension of electric field. These are the dimensions of electric field. So, we got to know the concept of electric field. We got its qualitative definition. We got its mathematical definition. Then we studied about its unit. Then we obtained its dimensions. So let us now come to its characteristics. You can take the screenshot. As we got to know the concept of electric field, we have to define its direction. What should be the direction of an electric field? So what should be the direction? Direction of electric field. So we are going to find the direction of electric field of a source charge. So let us define that source charge. Then there is a charged body whose charge is Q. It is situated at a point, at a given point, and we are going to find electric field at point P and define its direction. Whatever may be the magnitude of electric field, but we are going to define its direction. So what should be that direction? So let the source charge is positive. Let that source charge be positive. So in this vicinity, in its vicinity, इसके आसपास में हम एक यूनिट पॉजिटिव टेस्ट चार्ज को रख लेंगे. एक यूनिट पॉजिटिव टेस्ट चार्ज को ऐसे ही छोड़ देंगे. कीपिंग दिस चार्ज स्टेशनरी, सोर्स चार्ज स्टेशनरी रहना चाहिए. सो अगर आप इसको ऐसे रख देंगे और इस पे आप कोई फोर्स अपने आप से नहीं लगाएंगे, किसी और फोर्स नहीं लगाएंगे, तो देखेंगे कि ये इससे दूर जाएगा, कोई सा भी डायरेक्शन में दूर जाएगा. सो ये जो पाथ फॉलो करेगा, ये यूनिट पॉजिटिव टेस्ट चार्ज जो भी पाथ फॉलो करेगा, दैट शुड बी योर डायरेक्शन. If this unit positive test charge follows this path, then the direction of electric field is like this. Then the direction of electric field is like this. So एग्जाम में अगर कोई पूछे आपसे कि आपको एक सोर्स चार्ज दिया गया है और आपको बताना है कि कौन सा डायरेक्शन होगा इस इलेक्ट्रिक फील्ड का, आपको ये कॉन्सेप्ट लगाना है. क्या कॉन्सेप्ट लगाना है? कि आपको उसके आसपास एक यूनिट पॉजिटिव टेस्ट चार्ज रख देना है. ये क्यों इस डायरेक्शन को फॉलो कर रहा है? क्योंकि ये पॉजिटिव चार्ज है, ये पॉजिटिव चार्ज है, दोनों के अंदर रिपल्सिव फोर्स है और ये इसको यहां से दूर करना चाहता है. ये इसको यहां से दूर करना चाहता है और इसके दूर जाने के रास्ते को ही हम इलेक्ट्रिक फील्ड का डायरेक्शन बताएंगे. इलेक्ट्रिक फील्ड का डायरेक्शन बताएंगे. सो डायरेक्शन ऑफ इलेक्ट्रिक फील्ड के बारे में बाद में हम और भी चर्चा करेंगे. We'll discuss something more about the direction of electric field. So now let us find some other concept and get involved in those concept. Like we are going to find out the electric field due to a point charge. What should be the electric field due to a point charge? Like In the previous case, we considered a charged object having charge q. So let us consider that object we had considered is very minute, so that we can ignore its dimension, and it should act like a point charge. So electrostatic field or electric field due to a point charge, due to a point charge, लिख सकते हैं आप मेरे संग, थोड़ी रुकिए जरा, लेट मी रिफिल माय मार्कर. So why are we considering electric field due to a potential? Because it is the simplest case. We are starting from the first step. We'll take the simplest system and then take the complex ones. So electric field due to a point charge. Let be a charge Q be placed at any point O. This is a point O. It is an object is placed at that point, its charge is q, we can ignore the dimension, so it acts like a point charge. We are here, what is our motive here? We are here to find out the electric field of charge q at point P. We are going to find out the electric field of this charge at point P. So we have to bring in some, we have to take the help of a unit positive charge, like if we want to calculate the value of electric field at that point. So let us put let us put let us put a unit positive test charge, a unit positive test charge at P, unit positive test charge at P. Join them, join that 2 points, let that 2 points be separated by a distance r. Q is your source charge, Q source charge, whose electric field you are going to calculate, r distance of separation, and P is that point where you want to calculate that electric field. So you decide to put a unit positive test charge at P, a unit positive test charge at P. Since these are charged bodies or charges, there should exist electrostatic force between them, and that force is given by which law? Coulomb's law of electrostatics. So what is that force? F equal to K. I am going to consider that constant portion to be K. Don't bother about it. Q naught by R squared. This is the amount of force between these charged bodies, between the charges. So this is F equal to K Q naught by R squared. Up to this point you can understand it nicely. आपको अगर समझ नहीं आएगा तो मैं फिर से रिपीट कर दूंगा, हिंदी में भी रिपीट कर दूंगा. कोई सा भी आपको एक सोर्स चार्ज दिया गया है, वहां के एक पॉइंट है क्या O, और आपको निकालना है इलेक्ट्रिक फील्ड एट पॉइंट पी पॉइंट पे आपको इस चार्ज की वजह से इलेक्ट्रिक फील्ड निकालना है. तो आप ऐसे ही नहीं निकाल सकते, आपको क्या करना है, आपको हेल्प लेना है, किसी भी यूनिट पॉजिटिव चार्ज का हेल्प लेना है. तो आपने यहाँ आके एक यूनिट पॉजिटिव चार्ज को रख लिया, एंड बाय द हेल्प ऑफ Coulomb's law of electrostatic forces, you find the amount of force between these two charges. दोनों चार्ज के अंदर कितना फोर्स है आपने Coulomb's law के हेल्प से खोज निकाला. So as we know What is electric field? We know the qualitative definition of electric field, the mathematical definition of electric field, that is E equals to F by Q naught. F by Q naught. चलिए लिखिए आपका वैल्यू के क्यू नॉट बाय आर स्क्वायर डिवाइडेड बाय क्यू नॉट. देख सकते हैं न्यूमरेटर डिनोमिनेटर में क्यू नॉट कैंसिल हो रहे हैं. दैट इज के क्यू बाय आर स्क्वायर. This is the value of electric field due to a point charge. This is the value of electric field, and this is what we started, and this is what we wanted to derive. So at last in SI, let us write the value of K, that is 1 by 4 pi epsilon naught Q by R square. If you have been stated in any question that you need to find the electric field of a given charge like 5 coulomb at a distance 5 meter, then you are going to use this formula. Okay, you are going to put the value of charge here, you are going to put the value of distance here, and just simply put in the constant value, multiply it, you are going to get the answer. You are going to get the answer. So what is the value of electric field? E equal to 1 by 4 pi epsilon naught Q by R square. This is the electric field due to a point charge. So you can take the screenshot, and then we will proceed into another section. We are going to find out electric field of various objects, of various charge distribution, and something like that. So let us meet into another section.